Alright, so as you might have already know, last class was your last class for this unit, so let's go ahead and get to some reviewing, just so you don't mess up your tests so badly. Anyways, let's go ahead and get started. So given the formula for the nth term, say the first 5 terms of the sequence, blah blah blah. So, easy stuff, gotta tell you. So, let's go ahead and do A. Wow. So A. So your answer would be 2n minus 3. So I will start on 0. So you have negative 3. And you would have 2n plus 1, negative 1, 1, 3, and 5. And for B, we're going to have a quadratic function, by the way, if you didn't know that. 3, 4, 7, 12, and 4, 16, 19. Alright, so you notice it and be like, okay, wait a minute. The first one's arithmetic, but the second one, is it? Nope, it is not arithmetic. It's not geometric either because they are not multiplying by the same ratio. So be careful. Alright, now let's go ahead and now this is where we use a little bit of formulas. Let's go ahead and see. Look at this. So we know that Tn is it's a series, and Fn, it's one of the F words. It's a function, right? It's not a series. It's a function, because series, there's always relationship between the terms. So for example, for A, I could go ahead and graph it for you. I'm sorry. Look at this horrible pen. Wow, I just can't draw a straight line. I'm sorry. Not an art student here. All right, there we go. Now it's straight. Anyways, so when you have something like A that is relative to n, you would obviously have a linear function. We study enough to know, oh my god, that is not linear, I apologize. We would obviously have a linear function, something like this. When you have B though, you look at this and you're like, wait, that's not a sequence, that's a function. And obviously, you know, everything they put here, some of your teachers, they might just put a function on your test and you're like, wait a minute, hold on. That's not a sequence, and then that's what they do to confuse you. Alright, so given the formula, let's find the nth term. So the nth term right here we want to find is a 12th term. So T12 is obviously equal to 4 plus 3, 3, 12. And that is 36. So 40. Right, pretty easy. And f of n, you might be stunned for a second, but really it's nothing. You're basically just plugging in n equals 12. Right, so f of 12 is going to go ahead and equal to 12 plus 1 squared, and 13 squared is 169. Right? Simple. Alright, now let's move on to 3. So find the indicated terms. This is nothing. All you gotta do is use the formula right there that they just give you. So no big stuff. I'm gonna skip 3 for you. 4. 4 is pretty easy. It's arithmetic. I'll do a hard one. Wait, hold on. There's so much functions here. It's not good. I'll do C and D for you. So C, we're gonna have the first term being, I'll put 1 just so it's better. 6, and then we will have 2, so 6, 12, and then we'll have 2 to the 3 power, so that's 2 to the third power. 2 to the second power. So that'll be 4 times 6, 24. And, 48, and 96. Right? Note our common difference. Sorry, our common factor right here. It's actually it's 4. You didn't notice. Anyways, let's go ahead and do do D. First term where we have, I'll do n equals to 1, just so it's cleaner, because I don't want to work with bad stuff. So 10, so that would be 10, and 2 is a negative 20, positive 40, negative 80, and 160. Alternating sequence. Alright, let's go ahead and talk about the number 6. So find a formula for the nth term. So this is just applying formulas that you already learned. Note that there's only 2 formulas that we can talk about. So Tn is equal to a plus n minus 1d, or Tn is equal to a r n minus 1. Right? These are the formulas that you're going to use, and you're going to go ahead and find that. So basically, really what's here is really easy. As long as you can, on your test day, go ahead and memorize out these formulas. Right? As long as on your, oh my god, why am I lagging so much? 2a plus n minus 1d and blah blah blah, and then the geometric sequence. As long as you've gone on your test day, you can write these out. You should be able to do this pretty easily. However, there are here some word problems that I really like to give to you. Also, if you're bored of this and you're like, oh look, not enough practice, go ahead onto your textbook. There's challenging problems. They labeled it as challenging, extra challenging problems for you. So let's go ahead and read this textbook question. So when Dr. Roberta Bondar flew on the space shuttle, it lifted off at about 10 p.m. or 10 a.m., then orbited Earth at once every 90 minutes. That is pretty fast. So at what time of the day did it complete its 9th orbit? Obviously, just saying, you could play this dumb and just add 90 minutes. Or you could play it, okay, I guess listing out as a function it's probably dumber. But yeah, that's what we're gonna do. So we're gonna do the questions they intend us to do it. So we look at it, and we're like, okay, so we're adding something every 90 minutes, right? One orbit every 90 minutes. What is this? This is not a common factor. This is a d. This is a d value. This is a common multiplier. Sorry, this is a common. I forgot what's called. Doesn't matter. So our d equals to, if you mind, 90. Let's convert it into hours because we're in hours right now. Let's go ahead and convert it to 1.5 hours. Right, so we have our d value. So a huge thing to make sure that, when you are doing math and all that, it's cool. It's cool to have all of your constants here and there. That doesn't really matter. But when you're doing math and all that, it really comes to realize that, hey, wait a minute, I need my units to balance out. I can't have an hour here, kind of minute there, then I have a seconds there. Whoa, my math is wrong. We can't do that, unfortunately. So, sorry. So we'll have to work it out. So we converted that to hour, and our A is obviously 10 a.m. Assuming they're using the 24 hours schedule. Anyways, so that's that. And then at what time of the day will it complete its in, which is 9th orbit? 9. Right? And now this turns into a serious problem. So we want to find what time of the day. So we're not trying to find the sum here. Instead, we're trying to find the term here. Right? So Tn is equal to A plus N. So we will have A goes to 10 plus M, which is 9. What is this here? Doesn't matter here. D, which is 1.5. Sorry. And that is for you to find out. So 8 times 1.5. 8 times 1.5. That is going to go ahead and give you 12 plus 10, so 22. So at 10 p.m., that is how long you take. So look at this and think about it. Is this right? And you realize, wait a minute, if I have 90 minutes and that is 1.5, if I take 90 minutes and I completed my 9th orbit, wait, hold on, then I must have a prime number, right? Because 90 times 9 is gonna give us 810 minutes. And 90 being 1.5, 1.5 multiplied by 9, what is that? 1.5 multiplied 9 is 13.5. So this is where, when you do a series question, it doesn't work anymore. And now you know, hey, wait a minute, this is for the term number. That's not it. We completed the 9th orbit, right? We can't just do the term of 9. The term of 9 is when it started. But we completed the 9th orbit, so essentially we must add another 1.5. So instead of finishing at 10, which would take us 12 hours, by the way, and if you want to add it up by yourself, sure, go ahead. Let's actually add it up by ourselves. So 90 minutes per orbit. So it's gonna take us 9 whole orbits, right? We're gonna finish 9 orbits. So it's gonna take us 810 minutes, and we're gonna divide that by 60. It's gonna take us 13.5 hours. If we start at 10 and we add 13.5, we're gonna have 23.5. In our case, which is 23 and 30. So we're gonna end up at 11:30 p.m. See, so there are limits of mathematics, clearly, and when it comes to word problems, it's very great that you think about it intuitively first to see if your answer does feel okay, it's intuitively right, or no, it's counterintuitive. Anyways, let's go on to bacterial culture. This one's not as interesting, just a simple doubling period. So doubling every 30 minutes. Okay, so A is our 10,000, and we want to find out the time. So we find out the time. So it takes us 4 hours. So 2 ways to do this. Again, if you want to do it the dumb way or the serious way. Dumb way, actually, most of the time for me, I realize that dumb way is actually much more accurate than the stupid way. Okay, not the stupid way, but the series and whole magical mathematical way. Right? Sometimes I find that even easier than what I do. So, anyways, doubling period is gonna be something out of 30. Well, I guess you could say 0.5 because we do want to be in hours. 0.5 hours. So in hours, and you have to state this in hours. Note that there is a 2 here to raise to this power. So we look at it and we're like, okay, from 20 minus 16, that's 4 hours, right? 4 hours, so 4 over 0.5, that is 8 doubling periods. So 2 to the power of 8 multiplied by 10,000, it's what you want to be solving for right here. So 10,000, I believe 2 to the power of 8 is 256. So you're going to go ahead and at the end get 2.56 mil of bacteria. Now, achievement check. Let's go ahead and do this. If a number is added to every single term in a geometric sequence, is the resulting sequence geometric or is it arithmetic? So one problem about these questions is that you could always do it, obviously, mathematically and be like all of that. But when it comes to explaining or proving perspective, sometimes doing it in math it's just not enough. So a thing that I love, and I really love this. So I love to do is just to do it, write it out. What if I had just make up a sequence, right? When they define geometric sequence, they don't define which sequence they want. They define it as a generic term. So generally speaking, it should apply for all geometric sequences. So let's go ahead and make up a geometric sequence that we want. So 2, 4, 8, 16, right? The simple even number multiplying by 2 type of thing. Very simple, the most basic you will get. Let's go ahead and add a term to every single one of them. 3, 5, 9, 17. So just by 4 terms, we can already see this breaks every single rule that we know. Right? So you look at it and you think, okay, 3 times a number equals 5. And then 5 times that number is equal to 9. And then you're like, okay. So 3 times obviously 5 over 3. So 5 times 5 over 3 will actually give you 25 over 3. And that's not 9. Obviously, if it's 9, it will be 27 over 3. Right? And then 5 times x equals to, so 5 multiplied a random number is equal to 9. So obviously here, what we're multiplying by is 9 over 5. And then we see this, so we times it by 9, it's 81 over 5, but that's clearly not 17. So we look at it, okay, we can conclude, no, it's not a geometric sequence. And we look at it, can we add 2, what is this, add 4, and add what, add 8? Wait a minute, we can add it here, but it doesn't matter because our term isn't a constant. Right? It isn't a constant. Instead of being it, this is what it is. Right? This is what we have. Somehow we created a geometric, right? Did we? And then you look at it. No, it didn't. If it was geometric, it would have been 3, 5, 7. But now what we have here is 2 to the, instead of 2 multiply something, it's 2 to the end. And you look at this, this isn't a geometric sequence, this isn't an arithmetic sequence. This is a mixture. This is some of a weird hybrid thing. Right? So this isn't both. Anyways, let's go ahead and move on to the next question. If a number is multiplied by each term of an arithmetic sequence, is the resulting sequence still arithmetic or is it geometric? So let's go ahead and give us an example. Now let's say I multiplied every number by 2. You look at it, okay, it still remains its arithmetic properties. All of the differences are 4, 4, 4, 4, right? It's still arithmetic. And if it's arithmetic, it can't be geometric because you can't be both. You can be either one of them. Right? Just prove to that. If an arithmetic sequence is added to a geometric sequence, term by term, is the resulting sequence arithmetic or geometric? As we proved earlier, it is not. It's a hybrid. It's a weird hybrid of both. Let's go ahead and add it. Let's just go ahead and do this. Let's go ahead and add it. Realize this is 4. This is 6. This is 10. This is some weird hybrid, right? This is not what it is. This is some weird hybrid. So we look at it and we think, okay, so when a geometric is added to an arithmetic or arithmetic is added to a geometric, term by term, nope. The sequence, the resulting sequence will neither be arithmetic nor geometric. And these are pretty easy, the recursion formulas, except for the fact they're just put in here because they didn't have any recursion formula test here. These are only the sums because some teacher apparently skips recursion because they think it's way too easy. It's just pure intuitive sense. So anyways, that was pretty much the review of your test. I hope you guys do a great job on your test. It should be a free unit for you to boost your marks up. And next unit, we're going to move on to financials, where I will be giving you some financial advices, and we get to look into real-world application of mathematics. Wow, what a once-in-a-lifetime experience. Anyways, have a wonderful day. Wonderful.